I'm Mark Cavanaugh for Cavi Coaches, and today I'm going to coach you up on using Newton's second law along with friction equations and Newton's first law for a pretty complicated problem. Today we're going to apply Newton's second law, Newton's first law, and the friction equation into one complicated problem. So this is kind of like a puzzle. You're going to want to build a jigsaw puzzle with the framework that we've learned so far. So here's the problem. We have a box that has a mass. All symbols is being pulled with a tension force at an angle theta. And we're deriving an expression for the acceleration in terms of this given symbols that we have. Now, you have the tools that we've learned in the previous videos to be able to do this. So we're going to follow the steps that we've done for every other problem. We're going to draw a system schema first. So with system schema, we have four forces. There's a frictional force because we have a mu value. We have a normal force, gravitational force, and a tension force. So now we're going to draw our free body diagram. The tension pulls up and to the right. Normal is on the y-axis. Gravity points to the center of the earth, and friction to the left. Now we're going to draw our working free body diagram, because remember, our free body diagram is the answer to a problem on a free response. So we add our vector components on our working free body diagram, ft cosine theta and ft sine theta. After we've added our vector components, now we're ready to build our framework. And our framework is going to involve three equations. We're going to have the x direction equation, the y direction equation, and the friction equation. So we write the generic equations. So we're going to add up the forces in the x equals max, adding up the force in the y equals may, and friction equals mu times the normal force. So looking on our free body diagram, ft cosine theta minus the friction force is equal to mass times the acceleration. And then the normal force plus ft sine theta minus the mass times the acceleration due to gravity equals 0. Now the box accelerates in the x direction, so we rearrange that equation to solve for acceleration. Now our final answer here, at this point you might say, okay, I'm done, I found my acceleration, but friction force cannot be in my final answer. So my next step is I'm going to go to my y direction equation. I'm going to solve for the normal force. So I solve for the normal force. Normal force is equal to gravity minus ft sine theta. Well, that doesn't help me either. So now what I'm going to do is I'm going to go to my frictional force. And I can substitute in the normal force value I just found for the frictional force. So the frictional force equals mu k times the normal force, that expression we found in the y direction. So now I can substitute the frictional force value I found from the friction equation and the y direction equation back into my expression for acceleration. So the acceleration is ft cosine theta minus mu k mbg minus ft sine theta, all divided by the mass of the box. Now, when deriving an equation, you have to show all steps. So you want to show as much work as possible. Don't skip steps and move things around that you're unsure of. Make sure that you solve. The word derive means show all your work. Most likely, all the points are in the work and not even a single point is awarded for the correct answer. It's just wanting you to be able to show that you can derive by applying Newton's first law, second law, and the frictional equation. So you can see our overall acceleration equation now has just the variables we're allowed to have, which is ft, theta, mu k, mb, g, ft, theta, and mb are all allowed in our final equation. So this was how you solve Newton's second law problems using the first law and friction. I hope this was very helpful, and I hope you have a great day and an even better tomorrow.
If you found this video helpful, don't forget to click the like button down below and subscribe to my channel, Cavi Coaches, and follow me on Instagram and Twitter at Cavi Coaches.